Hi guys, welcome to another video. In this video we're going to talk about a short research paper I've written and analyze it together. It's a 7-page paper about EMA crossover lag times across correlated stock pairs. So let's go in detail of what I did. So we defined the EMA crossover as EMA 21, so exponential moving average is what I talk about with EMA, and EMA 9. And we have a bullish crossover when EMA 9 crosses over EMA 21, and the opposite happens with a bearish crossover. So we had different pairs analyzed with, and I'm gonna read some of them. So we have Ford and General Motors for automotive. We have banking with JP Morgan Chase and Bank of America, and we hope that they are moving together. This is the same logic behind mean reversion, but I took it with a turn. In fact, we're going to learn about machine learning with the nonlinear least squares, aiming to reduce SSR at the minimum. And I also found out that their derivatives are linked by volatility in some way. So I gathered all the lag times for this crossover to happen for these 10 pairs, and also the amount of crossovers totally. So by the leader, for example, if General Motors has a crossover, how much time it takes for Ford to have the same crossover, or if it happens at all within 30 days. So we observed 1,402 total events, no, 1,410 actually, that were matched, so within 30 days. And totally we had 2,206 events with a 63.92% accuracy. And we'll call this number tau from now on, and it's the probability that it lands a crossover within 30 days. So we have defined tau, and let's look at this graph over here. We can see all in the histogram the time it takes for it to cross over, but we can also see a curve plotted in magenta. This curve is a function we machine learned with non-linear least squares technique, aiming to, as I said previously, diminish SSR as much as possible. We define SSR as sum of squared residuals, so we keep the magnitude so they don't cancel out with the opposite sign. And we machine learned the coefficients for the whole universe and for the specific stocks pairs. Okay, so the function is of type 1 over 1 plus bx to the c. And for the, I'm only going to tell you the coefficients for the total events. So machine learned on 1,410 events, B coefficient is 0.4782 and C coefficient is 1.1197 with R squared as 0.9419. Okay, so after I looked at this, I also went to look at the individual graphs of everything. So I'm going to pull them up right now and subplots.html. Here it is. Okay. And we can see that the curve becomes less reliable and less steep the more the stock pair is more volatile. I noticed this looking at, for example, XOM and CVX, which was a pretty normal curve, also V2MA, and these are tickers I'm talking about, are Pep and Coke, Pepsi and Coca-Cola, pretty linear. But then if we look at something like AMD and Nvidia, the curve becomes much less reliable and the crossover is a bit all over the place. So it's less steep at the start. So let's put this into quantitative language. We can define it as the absolute value of the derivative of the function at point 1 is inversely proportional to the volatility of the stock pair. So now that we've seen with these 10 pairs that this happens, can we find a coefficient k such that volatility equals k times magnitude of function? Well, no. I machine learned that with regression, the way we did nonlinear least squares. But the thing is, the error was very, very elevated. So it is not a reliable um, predictive engine to understand that. However, we can see that although other factors alongside volatility influence the steepness of the curve, volatility still influences the curve, making it less steep. At this point, the most important thing about this paper, I think, is understanding something very crucial in my opinion. So we have seen this curve. I'll pull up the notebook here. We have seen a curve that does like this. This is the y-axis and this is the x-axis, and we have our curve. So here we are at day 0. How many crossovers on day 0? How many crossovers on day 1? And actually 0 equals 1, it's shifted by 1, the x-axis in the graphing. So we can confidently say at day 30 the function stopped existing because we don't need it anymore. The 1 minus tau probability occurred, and this whole thing is tau. So we can have individual tau for the stock pairs, but also tau for the total universe. And with this happening, we can say, let's say we have day x over here, day x. What is the probability that a crossover occurs before day x? Well, we can look at the area of the graph and we can see I have colored in the area before day x. So we can model this with integration, which tells us the area under the graph. And it's actually easy to find the antiderivative of this function because we can apply the power rule since we do not have directly 1 over x, as c is not 1. Having done that, we can find that assuming tau event happens, the probability of x being less than k, where k is our chosen day, is the integral from 0 to k of f of x dx over the integral from 0 to 30 of f of x dx, with f of x being 1 over bx to the c, where b and c I've specified them before. And we can clean this up a bit. In fact, since the bottom denominator is a constant, we can model it as assuming tau occurs, p of x less than or equal to k is equal to 0.205, that's the reciprocal of the integral from 0 to 30, times the integral from 0 to k of 1 over 1 plus 0.4782x to the 1.1197 dx. And we can find the antiderivative. After that, we can model at what day does it become statistically suboptimal to hold the position because it's more likely for the crossover to not occur. That day is day y, we'll call it day y, and we assume on another graph we have gotten to a day where we want to understand, is it optimal for us to hold? And this day is y, and it's the breaking point. So we know this whole bit here is tau, all right? So if it happens after day 30, it's 1 minus tau. But here it's not specifically tau, it's tau times the integral from y to 30 over the integral from 0 to 30 of f of x dx. So we can model the inequality tau times the integral from y to 30 of f of x dx over the integral from 0 to 30 of f of x dx is less than 1 minus tau, and we can solve for y to get the day where it is statistically suboptimal to hold the position. After this, we can draw some conclusions. I'll leave the research paper in the description if you're interested in it. So we have a predictive temporal window. In fact, we have 63.92%, so basically 64% chance that a crossover happens before day 30, which is pretty good predictive power across 2,209 events looked at. Wait, maybe I got it wrong, but no, 2,206, sorry. And we have the nonlinear least squared is not super accurate, but it still gives us an idea of what happens. The r squared is 0.94, and the volatility multiplier effect is another conclusion we can draw. In fact, the magnitude of the decay derivative f prime of 1 at point 1, and the magnitude is inversely proportional to the volatility. And I chose to put it in terms of magnitude because derivative is negative there, but I'm talking about how steep the line is, so I wanted to invert the sign to make it more intuitive. Then we have execution framework. Well, we can use this in trading um, to model when it is statistically optimal to expect a crossover. And I will bring a video about backtesting this strategy. And then we have asset specific optimization. In fact, we can find better curves for individual assets in the subplots I've plotted before. But the general equations with the coefficients I have cited of B equaling 0.4782 and C equaling 1.1197 can fit the general um, population broadly, although this becomes less predictive on higher volatility pairs. And then we have the most important conclusion, in my opinion, is the suboptimal holding or rising Y exit rule. So once the Y can be solved for, tau times the ratio of the integrals is less than 1 minus tau. And this will tell us when Y, which is on the top integral, is the break day. So thank you for having watched this video, and be sure to like and subscribe if you like this type of content, and please comment what I should bring next and what you thought about this video.